Alright, hey guys, this is Wednesday, April 15th for geometry. And so today's lesson is on similar triangles. And so this is going to be a lot similar to when we did congruent triangles. We're basically going to have the same acronyms basically. The difference is that instead of them all being exactly the same, they're going to be in proportion to one another. And so the big key here is if you look at postulate 13.1 on page 542, it is the angle-angle similarity postulate, and it states if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. And so again, if we have the AA similarity postulate, is if we have two angles that are congruent, meaning they have the same measure, then we can say the two triangles are similar. And so here I have angle A is congruent to angle D, and then I have angle B is congruent to angle E. And so that gives me two angles that are congruent, so I can say that these two triangles are similar. And so that means they're going to be in proportion to one another. So that can tell you that these two are going to be similar. And so if you have two angles that match two angles in the other triangle, then that tells you that those two triangles are similar. So I can say that triangle ABC is similar to triangle DEF. Alright, so that is your angle-angle. Now, for our next one, look at theorem 13.1, and that is the side-side-side similarity theorem. And it states if three sides of one triangle are proportional to corresponding three sides of another triangle, then the triangles are similar. And so that is right here. So I drew triangle ABC again, and then I drew a triangle DEF. So what happens is if AB if the corresponding sides are similar, then or the same ratio, then that means the two triangles are going to be similar. So for example, we'll make it a little bit easy to just comprehend it. If I said that AB was 2 and DE was 4, then when I set up the fraction AB over DE, I'd get 2 over 4, or 1/2. So that means for these to be similar, it has to match that ratio all the way around. And so I would have to have AB, that ratio equaling DE. I would have to have BC, we'll say is 5, and it has to match EF. And so EF would have to be 10. And so, because remember, it has to reduce to 1/2. So 5 over 10, BC over EF, 5 over 10 now, would have to be 1/2. It is. So those two are equal. And then AC would have to be, AC over DF would have to be 1/2 in this case too. So if I said this was 6, then this would have to be 12. And so AC would be 6. FD would be 12, that also reduces to 1/2. So basically the ratios of the corresponding sides have to be in the same ratio. That has to be proportionate. If that matches all the way around, then we can say that those two are similar triangles. And so these two would be similar triangles because of the side-side-side similarity postulate, which says if each side's corresponding sides are proportionate to the rest of them, that means equal to the rest of them, then it's similar. And so basically the 2 over 4 would have to equal 5 over 10, would have to equal 6 over 12. If that reduces to the same number across the board, then that would be your side-side-side theorem. Your next one is on page 545. This is the side-angle-side similarity theorem, which states if two sides of a triangle are proportional to the corresponding two sides of another triangle, and the included angles between the sides are congruent, then the triangles are similar. And so that would be like this one. And so see, notice what happens on this. Notice that my angle A is congruent to angle D, so A and D have the same measure. So that's important. And so the next step is that the sides that make them up have to be in proportion to each other. So in other words, if this is the angle that's congruent, that means the two sides that make up that angle have to be proportionate, have to have the same ratio when we set it up. And so C, that means that AB over DE has to be the same as AC over DF. So in other words, to just use easy numbers, if AB was 5 and DE was 10. So that means that reduces to 1/2. So AC and over DF must reduce to 1/2 as well. So if AC was 6, then that means DF has to be 12. So notice when I do that, AB over DE, 5 over 10, 1/2, and then AC, 6 over 12, 1/2. If those match up, then and you have that angle in between being congruent, then you can say that those two are angle side similarities. And so that'll get us through the theorems and definitions. The last theorem there is similarity of triangles is an equivalence relation. And then it gives you the table there, 3 quick ways to prove that the triangles are similar, and it just gives you the illustration of what I just said. So, looking at your homework, you have 1 through 6. They give you the 3 sides and ask if these are similar. So what we have to do for that, you have to do this. So we have to take each side and put it over it and see if it reduces. So for like number 1, you would have to put 3 over 12. And then you would have to put 8 over 32. And then you would have to put 7 over 28. Reduce it. If those all reduce to the same fraction, the same ratio, then that means that would be a similar triangle. If it does not reduce to the same ratio, then that is not a similar triangle. So that gets you through 1 through 6. Now 7 through 12. 7 through 12, you're dealing with, they actually give you the triangles. And so you have to be able to identify, okay, if they give us two angles that are congruent, we can say it's similar because of angle-angle. If they give us one angle that's congruent and the 2 fractions match up when we do the ratio, then that would be similar because of side, angle, side. And then if they give us all 3 sides and they match up the ratios, then that would be side, side, side. And so you just have to actually work through it the way I did on the board. If it works where it doesn't work, so for example, I don't know, for this one, say this was 8 and this was 12, then notice now we had 5 over 10 is 1/2, we had the angle, but then the 8 over 12 doesn't reduce to 1/2. So that would be not similar because it didn't match the side angle side. That portion failed at that point. And so you're just going to work it through, make sure that the fractions match, their ratios match, and that's pretty much as simple as this lesson is, really. And so your homework then is going to be 1 through 13. I did give you one proof to try, so try number 13, try the proof, and just try that one on your own and just see how we can do on that, just so we still have some of that here and there. And so that is today's lesson. And so if you have any questions, get with me. Again, your assignment is 1 through 13 on 546. Thank you all.